So if you look at number 1, we did have a hole on the graph. And so when we do increasing and decreasing intervals, we're going to notice that the things that affect your increasing and decreasing intervals are going to be holes and vertical asymptotes, because those are values that kind of get skipped. But then also maximums and minimums are going to affect your increasing and decreasing, because a maximum is where the graph changes from going up to going down. So we're going to find that those are the different things that we'll keep in mind. So if you look at this, what is the x value over here at this left arrow? Negative infinity. And if we look at our little stick figure, he is walking down, so he's decreasing. And he walks down until he hits the hole, and then he falls through the hole and dies. So what is our first set of parentheses for decreasing? Okay, so there's our first section. And then, I don't know what happens to that first guy. He's dead. But then we get a new stick figure. He's green. Can you guys tell he's different? And he climbs out of the hole. I don't know. He like steps on the other guy and climbs. I don't know. So he starts at an x value of -1. And what is he doing? He's decreasing also. And what x value do we see at the end? Infinity. And so over here we're going to say u -1 to infinity. So on this graph, 2 different sets of parentheses because the hole separates them, but both of those were decreasing. Okay. All right, on the next one, if you have not drawn in the asymptote, you need to do so now. So there should be a vertical asymptote drawn in there, and then you should also have a hole drawn in. And we draw those in because they do affect the increasing and decreasing, so we want to make sure that we have them to reference. So when we look at increasing and decreasing, we always read the graph from left to right. So the very furthest to the left that I can see is negative infinity. And I've got my little stick figure. And he's walking which way?
Down.
He's decreasing. And he decreases and he's getting closer and closer to this dotted line, and then he walks on the dotted line forever and dies in a desert. I'm not sure. So what is the x value that's happening right there? Yeah, -1, right?
Yeah.
-1, okay. So again, I can see that this value here is an arrow that's going down, but I'm not talking about up and down, I'm talking about left and right. So the x value right there was -1, even though I can see an arrow right there. I'm still talking about the x values, that's -1. So the decreasing answer that we can start with is negative infinity to -1. And then we have a new stick figure up here because the last one died. And what is the x value that this new stick figure is starting at? -1. And what is this new stick figure doing? Yeah. Decreasing. Now, Katie said he's decreasing till 3. Can someone else explain what she meant by that? Yeah, he falls through the hole and dies. Okay, so we're saying decreasing from -1 to 3. Okay. And then my green. And then he falls through the hole and dies, and then a new stick figure steps on top of him and climbs out of the hole. So the new stick figure is starting at 3 and going to what x value? Infinity. And what is this stick figure doing? He's walking up or down? It looks straight, but what do we know about asymptotes? Yeah, so the curve gets closer and closer to 0. So he is walking down, but very, very slowly. It's like when you're taking a walk and you're doing like a slight decline, you know? You guys ever know like when you're riding a bike and it's just like a little bit too easy, so you know when you turn around and come back, it's not going to be easy again? You know what I'm talking about? Like you don't feel like you're riding down, but it's a little bit easy. That's kind of what this is. So it's decreasing, it's just decreasing really slowly. All right? So we're going to say this decreasing is from 3 to infinity. All right. I want to skip a couple pages because I want to show you guys one that uses maxes and mins. So we're going to skip to page 6. Not page 6, problem number 6. Oh, that's problem 10. I lied. Problem 6. There's problem 6. Okay. So again, when we do maxes and mins, we need to have our asymptotes drawn in. And the maxes and mins should be labeled. So I have a minimum at -6, 3, and a maximum at 0, 0. Okay, so we start on the left side of the graph. So I start over here with my stick figure. And what is the x value over here? -infinity. And when he starts walking, which direction is he walking? Wait, look right here. Which way is he walking here?
Down.
He's walking down. So he's decreasing. And then what happens after he hits this x value right here?
Starts increasing.
And then he increases. All right, so he decreases until he hits that minimum, and then he switches directions. Say it again. Yes, you're right, but we have to make sure we use the x value. So when we're going to say he is decreasing from -infinity to -6, because we're using the x coordinate. So decreasing -infinity to -6, and then our increasing is from -6, and then what's the x value of the dotted line? -3? Okay. Now, why would we have maybe slipped and said infinity when it's supposed to be -3? What's the difference? Because I do see an up arrow right there, so why should I not call that infinity? That's up and down. We want to do the x value. Okay, that's an easy mistake to make. We want to make sure we're using x values whenever we talk about our increasing, decreasing. Okay. Yeah. Yeah, when you talk about things like increasing and decreasing and x-intercepts, you are often talking about where on the graph those things are happening, and it's easier for us to locate an x value. We say, oh, at that x value, that's what's happening. Now, if we look at this minimum point right here, it was actually on the graph, but I did not put a bracket. Does anyone know why I didn't put a bracket? Because it's increasing, decreasing. We never put a bracket on there. Do we remember why we don't use a bracket on increasing or decreasing? What if I cover up everything else? I just look at this point right here. Can you guys tell me? Yeah, if you look at that point, does that point slant up or down? No, it's just a little dot. How can it slant? So that's the reason we don't use brackets, is because I can't say, oh, if I put my finger on -6, I can see that that point on -6 is slanted up. Points don't slant. That's why we use parentheses, not brackets. Okay, so that stick figure got up here to the dotted line, and then he went off forever and then died in the desert. So now we have another stick figure, and where does the next stick figure start? Yeah, he starts right here at the bottom because this is the left side of the next curve. Okay? So we always start at the left side. Now I see an arrow going down, but I'm not going to use -infinity. What am I going to use? -3, because that is the x value, and I only use x values. Okay? So, and what is this stick figure doing? Going up. So this is increasing. So increasing from -3 up here to this maximum point, and then he starts decreasing. So for increasing, we're going to say -3 to 0. And then decreases from 0 to infinity.
So the reason we don't
The reason we're not writing infinity is because the infinity is the y value pointing down. Down is y, and we're using x values to describe it, and this x value is at -3.
I don't know, like for the increasing, like is that infinity? Is that because like the asymptote there?
This infinity right here,
Both ones are going away from the asymptote there. Is that increasing?
it's because this one is infinity because it's a left arrow, and left arrows are -infinity, and this one's infinity because it's a right arrow, and right arrows are positive infinity.
I mean, like with the asymptote in the middle, the reason it's not infinity is because of the asymptote.
No, it's the reason that it has an arrow there is because the asymptote, because it's getting closer and closer to the asymptote, and the reason we're not using the arrow as our description is because it's a y value, not an x value. Yeah. So when oh, where was the hole at? Oh, it was positive 3. There was a hole right here. Now, the nice thing, oh, that actually does affect your answer. Dang it. Okay, let's go back. Sorry, that was my bad. So I missed the fact that there's a hole on it because I did not draw it on my paper. This is why you always have to draw it because it'll mess you up if you don't draw it. So how can we fix our answer to show that we have that hole in there? 0 to the hole at 3. So it's this decreasing answer right here is the one that I messed up. That was my bad. Yeah, so we would say it's from 0 to 3, and then that stick figure dies, right? Falls through the wall and dies, and there's a new stick figure, and then 3 to infinity. That was my bad. So sorry, guys. Okay. So remind me again, what are the things we have to watch out for when we do increasing and decreasing? Holes, asymptotes, max and min. Okay? So and we could write this in our packets. So numbers that are skipped, what are numbers that are skipped in the increasing and decreasing? Holes. Holes are numbers that get skipped. What's another number that gets skipped? Asymptote. Yeah, vertical asymptote. And then what are numbers, let's say numbers that change direction? So numbers that get skipped, holes and vertical asymptotes. Numbers that change the direction would be maxes and mins, because either you're going down and coming up for a min, so going down would be decreasing, coming back up would be increasing, or you're going up and then coming back down for a max, so you're increasing then switching to decreasing. Okay? So we got numbers that get skipped, we got numbers that change the direction you're going. All right? Okay.